It's pretty amazing how fast virtual reality is moving, isn't it? I mean, it's really branching out from just, games.
Oh, definitely.
You see VR getting cheaper, easier to get hold of, and this whole idea of using it for learning, well, it feels like it's really starting to take off.
It really is a fascinating space.
So today we're diving deep into something specific.
Mm.
How do we actually learn physical movements inside VR?
Yeah, it's one thing to watch a video,
Mm-hmm.
right? But being able to, interact with a 3D object, turn it around, understand how it moves, that's different.
Exactly. And there's this really interesting study we're looking at today.
The one in Educational Psychology Review from June.
That's the one. And what's cool is they looked at learning in two kinds of VR. You've got your sort of low immersion desktop VR,
Right, on a computer.
and then the full-on high immersion headset experience.
And the key thing, I think, is that they weren't just asking, does VR work?
Hmm.
They were digging into how the different ways you can interact affect learning about dynamic movements.
Yeah. Like how something complex actually works. Or in this study, it was fish swimming, wasn't it?
Exactly, the kinematics of fish swimming.
Okay, so our mission for this deep dive, pull out the key stuff from this study. Figure out which interaction methods in VR help most with learning movements, but also factoring in the VR type and, importantly, our own abilities.
Yeah, those individual differences seem crucial.
So let's lay out the two main interaction types they tested. First up, object movement.
Right, that's where you basically grab the virtual object and, spin it around, look at it from different angles. Pretty intuitive.
And the other one?
They called it camera movement or viewer movement. So the object stays still
Uh-huh.
and you move your viewpoint around it. On the desktop, that meant using the mouse to sort of orbit the object.
Gotcha. Different ways to get different perspectives.
Exactly.
And it wasn't just about interaction A versus interaction B, was it? They layered in something else.
Yeah, our visuospatial abilities.
Oh.
Basically, how good you are naturally at visualizing things, mentally rotating shapes, understanding spatial relationships.
Like being good at map reading or Tetris, that kind of thing.
Sort of, yeah.
Yeah.
That inherent skill. They wanted to see if that affected how well each interaction method worked for different people.
So the big question is there one best way? Or does it depend on the tech, on us?
That's pretty much what this study tries to untangle.
Okay, let's start with the first part then. The desktop VR study, lower immersion, how did that actually work?
Right. Study 1, participants used a normal computer screen, mouse, interacting with these 3D swimming fish models.
And the different groups?
3 groups. One group used the mouse to rotate the fish itself, controlling pitch, roll, yaw, the whole lot.
Okay.
Second group used the mouse to move the camera around the fish, orbiting it. The fish stayed put.
And the third?
A control group. They just watched a preset animation of the fish swimming. No interaction at all.
Right, passive viewing. So in this desktop setup, what did they find? Was one method clearly better for learning?
Well, this is where it gets interesting straight away. Overall, not really.
Wow.
They didn't find a significant, across-the-board advantage for either object movement or camera movement compared to each other,
Okay.
or even compared to the group that just watched passively.
Seriously, so just watching was basically as good as fiddling with the mouse?
In terms of the overall learning outcomes, yeah, pretty much. It seemed like just observing was quite effective in this desktop setting.
That's kind of surprising. All that interaction potential didn't necessarily boost learning, but you mentioned visuospatial ability mattered.
Oh, absolutely.
Yeah.
That's where the nuances really started to show up.
Yeah.
Across the board, people with higher visuospatial skills, they just generally did better.
On all the tasks.
Pretty much. On the recognition tasks, easy, medium, and difficult patterns, and also on the factual knowledge questions. Being good spatially gave them an edge.
Okay, so if you're good at that stuff, you learn better, regardless. But did the way they interacted make a difference depending on their ability?
Yes, exactly. This is the really cool part. When they looked specifically at the difficult recognition tasks on the desktop,
Uh-huh.
there was a clear interaction. People with higher visuospatial ability performed better on those tricky tasks when they controlled the camera position.
Ah, so orbiting the object helped the spatially skilled people understand the complex stuff better.
It seemed to, yes.
Yeah.
But, and this is the flip side,
What about the people with lower spatial skills?
for them, controlling the camera actually led to worse performance on those same difficult tasks.
Whoa. So it backfired for them.
It looks like it.
Huh.
Maybe controlling the viewpoint without having strong inherent spatial skills was just too much. Maybe confusing, overwhelming even.
That is a key finding. Giving viewpoint control helps the high ability group, but hindered the low ability group for complex learning in desktop VR. What about the other conditions? Rotating the object or just watching?
For those two, object movement and the no interaction group, the results were pretty similar regardless of visuospatial ability.
Okay.
Neither rotating the object nor just watching seemed to particularly help or hurt one group over the other in the way camera control did.
Interesting. Now, they also measured other things, right? Like motion sickness, feeling present.
Yeah, they did. For motion sickness on the desktop, higher visuospatial ability was linked to feeling less sick.
Makes sense. Maybe better able to orient themselves.
Possibly.
Yeah.
And for those with lower visuospatial ability, they actually felt more sick in the no interaction condition compared to when they controlled the camera.
Wait, they felt less sick when moving the camera? That seems counterintuitive.
It does, right. But maybe having some control, even if it didn't help their learning on difficult tasks, helped reduce that feeling of sickness. Predictability, maybe.
Huh. Okay. And presence. Feeling like you're there.
Both interactive conditions, camera control and object control, led to higher feelings of presence than just watching.
That makes sense. Interaction pulls you in more.
Yeah, specifically, camera movement boosted spatial presence, feeling like you're in the space. Object movement seemed to boost more general presence. Oh, and also, if you already knew something got foolish, you felt more present too.
Right. Familiarity helps. Okay, let's try and unpack this desktop stuff. Why no big overall learning benefit from interaction? And why that specific split with camera control and ability?
Well, a few ideas. One possibility the researchers mentioned is that the view they chose for the no interaction group maybe it was just really good already.
Like the expert picked the perfect angle to show the movement.
Exactly. So maybe interacting didn't actually offer a better view for learning the basics. It just added cognitive load.
Okay, that's plausible. What about rotating the object with the mouse? You said pitch, roll, yaw. Sounds potentially fiddly.
It could be, yeah. Using a 2D mouse for complex 3D rotation,
Yeah.
it's not always the most intuitive thing. That interaction itself might have been tricky, especially for some people.
So the interface itself could be a barrier, and the camera control helping the high spatial folks on hard tasks.
The thinking there is that people with good spatial skills are better at building a mental 3D model. So giving them control over the viewpoint lets them gather the perspectives they need to build that robust mental picture.
Right, they can use the control effectively.
But for someone who struggles with that mental construction, changing the viewpoint constantly might just make it harder to form a stable understanding. More confusing than helpful.
Got it. Okay, so desktop VR, subtle effects, ability matters a lot. Interaction isn't automatically better. Now let's shift gears. Study 2. Immersive VR headsets on. How is that setup different?
Right. Big difference in immersion. Proper VR headsets, handheld controllers, crucially, stereoscopic vision, real 3D depth perception, and they could see virtual hands tracked to their own.
Much more embodied then.
Definitely. Felt more like you were actually in there.
And the interaction methods in this immersive world.
Two main ones, again, analogous to the desktop study, but more physical. First was object movement. You used the controllers, reached out with your virtual hands, and literally grabbed and manipulated the 3D fish.
Rotate it, pull it closer, whatever, with your hands.
Exactly. Very direct.
And the second method.
Viewer movement.
Yeah.
Here, the fish model stayed still in the virtual space.
Mm-hmm.
And you physically walked around it in the real-world tracked space. You could duck down, step side to side, use your whole body to change your view.
Okay, so proper physical movement versus direct hand manipulation. What about the learning outcomes here? Did immersion make a difference? Did one method win out?
Well, here's the echo from the first study. Again, overall, no significant advantage for either method.
Still? Even
No.
with the walking around and grabbing?
Yep. Looking at all participants together, neither manipulating the object nor walking around it led to consistently better learning outcomes compared to the other.
Huh, okay. But I'm guessing visuospatial abilities still play a role. It seems to be the recurring theme.
You guessed right. Big time. Just like on the desktop, people with higher visuospatial skills did significantly better on the difficult recognition tasks and the factual knowledge questions in immersive VR, too.
It's a really consistent finding then. Spatial skills are key for this kind of learning in VR, regardless of immersion level.
Seems that way.
But
Yeah.
was there that interaction again? Did ability level change how effective each method was, even if there wasn't an overall winner?
There was, yes. But it manifested differently than in the desktop study. This time, for the easy recognition tasks.
The simpler stuff.
Yeah. Learners with higher visuospatial ability did better when they were directly manipulating the 3D models with the controllers, the object movement.
Interesting. So grabbing the object helped the high-ability folks with the basics in immersive VR.
That's what it suggests. And it points towards something called the near-hand effect.
Near-hand effect. What's that? Sounds like what it says on the tin.
Pretty much. It's this idea from cognitive science that our brains pay more attention to and process things differently when they're within reach of our hands.
Ah, because we might interact with them.
Exactly. Evolutionarily makes sense. So for people already good spatially, having that virtual object right there in their virtual hands might have amplified their ability to process its basic movements effectively.
Fascinating. So direct interaction close-up helps spatially skilled people nail the fundamentals. What about the people with lower visuospatial ability in the immersive setup? Did walking around help them, maybe?
Well, there was a trend in that direction. It wasn't statistically significant in this study, but the data hinted
Okay.
that learners with lower visuospatial ability tended to perform a bit better on the medium difficulty tasks when they were physically moving around the object, the viewer movement condition.
So a suggestion that physically walking around might be more beneficial for less spatially inclined folks when tackling slightly more complex movements in VR.
That's the potential implication. Perhaps that more embodied, natural way of observing from different angles helped them build that mental model for the moderately tricky stuff.
Makes intuitive sense. What about presence and motion sickness in the immersive study? Always big factors with headsets.
Right. For presence, an interesting twist. Learners with lower visual spatial ability actually reported higher general and spatial presence when they were walking around the object, compared to when they were manipulating it.
Really? The lower ability group felt more present when walking.
Yeah, it seems that embodied interaction really boosted their sense of being there.
Okay. And sickness? Any difference between grabbing and walking?
In immersive VR, they didn't find a significant difference in motion sickness between the two interaction types.
So manipulating versus walking didn't change the sickness level much.
Apparently not. But overall, motion sickness was significantly higher in the immersive VR study compared to the desktop one.
Not surprising, maybe? More sensory input?
Exactly. And as you'd expect, presence ratings, all aspects, general, spatial, involvement, realness, were also way higher in immersive VR than desktop,
So putting the immersive findings together, what's the story?
it looks like. Potential near-hand benefits for high spatial folks on easy tasks using direct manipulation. For lower spatial folks, maybe a benefit from embodied movement, walking, for slightly harder tasks, and the constant trade-off. Higher immersion brings much greater presence, but also a bigger risk of motion sickness.
Okay. Now, the study also directly compared the two environments, right? Desktop versus immersive. What came out of that head-to-head comparison?
This is probably one of the biggest takeaways. When they directly compared learning outcomes, performance on recognition, factual knowledge,
Yeah.
there were no significant differences between desktop VR and immersive VR.
Wow. Hold on. So despite the headsets, the hand tracking, the walking around, the massive increase in presence, people didn't actually learn the movements significantly better than just using a mouse and screen.
Based on this study's findings, no. The learning results were statistically comparable.
That's huge. It feels like immersive VR should be better for learning physical things.
You'd think so, intuitively. But this study didn't find evidence for that in terms of actual learning score. However,
But the experience was different.
massively different, as we said, significantly higher motion sickness in immersive VR, and significantly higher scores on all the presence measures. People felt more there, more involved, more real in the headset.
So immersion ramps up the feeling, ramps up the potential discomfort, but doesn't necessarily ramp up the learning.
That seems to be the finding here. It really suggests that just throwing more immersive tech at a learning problem isn't a magic bullet.
Right. It's more complicated than that.
Exactly. How you design the interaction and how that interaction suits the individual learner's cognitive profile. That seems just as important, maybe even more important than just the raw level of immersion.
Okay, so let's try to pull this all together. What are the big takeaways for someone listening, maybe someone thinking about using VR for learning or training?
Well, the biggest one is probably that there's no single best way to interact with 3D models in VR for learning movements. It's not one size fits all.
And your own visuospatial ability looks like a really key factor.
Definitely. If you're naturally good at spatial stuff, the study suggests directly manipulating objects in immersive VR, getting your virtual hands on them, might be really good for grasping the basics, that near-hand effect.
But if you find spatial tasks more tricky,
then maybe physically moving around the object in immersive VR, or even just controlling the camera view on a desktop system could be more helpful, especially as things get more complex. It's about matching the interaction to your strengths.
And we can't forget the immersion level itself. Higher immersion means higher presence, which feels great.
But also that higher risk of motion sickness. It's a balance.
Yeah, a trade-off to consider.
Absolutely. And this research really hammers home a point for designers of VR learning tools.
Yeah,
We need to think about tailoring things.
personalization.
Yeah, adapting the interaction not just to the learning goal, but also to the learner. How can we make these environments work better for people with different cognitive strengths? That's a huge challenge.
Okay, here's a final thought to chew on. Our natural way of understanding objects is often, walking around them, looking from different angles. So why isn't that always the best way in VR? Why might manipulating it sometimes work better for some people? Or why might it sometimes be less good?
That is a really interesting question to end on. Maybe the act of translating our real hand movements through a controller to manipulate a virtual object. Maybe that adds a layer of cognitive processing, a mental translation step.
Like it's not quite natural, even if it feels direct.
Perhaps. Maybe the cognitive load of that translation sometimes interferes with the learning, especially compared to the more automatic process of just moving our bodies to get a different view. Or maybe, as the near-hand effect suggests, direct manipulation focuses attention in a way that's beneficial for certain tasks or learners.
So it's not as simple as just replicating reality.
Definitely not. There are subtle cognitive factors at play. Figuring out these nuances, when to use direct manipulation, when to use viewer movement, how to adapt it for different people and different learning goals. That's really the frontier here. Getting that right will be absolutely vital as VR becomes a bigger part of education and training. It's about making it truly effective for everyone.